Good day, everyone. We will be presenting our research entitled Evaluating Minutiae Count as an Indicator of Latent Fingerprint Degradation. To start, there are 6 of us in the study. Now I will discuss the introduction of our study. Humans have a very unique signature that cannot be forged by pen and paper. This one-of-a-kind signature is regarded as fingerprints. Fingerprints are friction-rich detail found in the hands and feet. In a court of law, these are considered as a reliable evidence. However, one problem encountered is the lack of certainty about the time in which the fingerprint is deposited unseen. On our study, it closely follows a 2015 study by the El Carrasco et al. That focused on the count of ridge detail as an indicator of degradation. Ratio was implemented rather than individual counting of the minutiae to lessen the impacts made by other factors such as hair and fiber, counting bias, and others. The variables that are first is light condition. It refers to the amount of light in the prints that are exposed to. It is divided into light, medium, and dark. Next is substrate, where the prints are deposited on. We made use of glass and plastic. Lastly, secretion type, meaning which gland the composition of the print is made up of. We categorized it to eccrine-rich, sweaty fingerprint, and sebaceous-rich, greasy fingerprint. We also identified 3 objectives. The first objective is to test which of the individual factors have a significant effect on the minutiae count when the effects of the other factors are not considered. Second, to test which of the combination of factors have a significant effect on the minutiae ratios. Third, to find out whether when the fingerprints on an individual finger are subjected to the same test, they will yield the same significance as they do when tested as a unit. As for the statement of the problem and hypothesis, it was based on our objectives.
I am like Pasinhan and I will be discussing about the materials and methods of this study. The participant of this study is a male that resides in Baguio City and within the age bracket of 25 to 29 years old. The non-probability sampling method was applied, specifically the convenience sampling technique, in choosing the participant of this study. The procedure of this study was subdivided into 4 phases. The first phase is the sample preparation, wherein we utilize non-porous substrates, specifically glass and plastic. We also focused on sebaceous and eccrine secretion types. For the sebaceous secretion type, the male donor's right hand was not washed for at least an hour prior to the deposition. The index and middle finger of the male donor were rubbed on any of the oily region of his face. For the eccrine secretion types, the male donor's right hand was asked to perform any exercise for the sweat to be expelled, after which the male donor imprinted his fingerprint onto the substrates. There are 2 deposited latent fingerprints coming from the index and middle finger of his right hand onto the glass, repeating this process for each of the 3 distinct environmental conditions that are going to be evaluated later on. This process was also done on the plastic substrate. All in all, there are a total of 24 latent fingerprints that were imprinted. The second phase is the environmental conditions, wherein we take the light exposure as our controlled variable. It was subdivided into 3. First is the light, wherein the latent print is directly exposed to sunlight. Penumbra, wherein it's not directly exposed to sunlight. And dark, wherein it is placed in an area wherein there is total darkness. The third phase is the latent fingerprint collection and development. The latent fingerprint were stored for at least 12 weeks with 3 discrete collection time every 4 weeks, and it was developed using silver black powder, after which it was photographed using a digital camera and a macro lens. The last phase is the image standardization and qualitative analysis. The photograph data is uploaded in an imaging software to enhance the image and for us to clearly see and identify the minutiae of the latent fingerprints that we have collected. For the statistical test that we utilize, first is the Mann-Whitney or the Wilcoxon-Rank sum test. It is a non-parametrical test that is used on 2 samples that are independent of one another. It's specifically conducted in order to determine whether which of the light condition, substrate, and secretion type, or a combination thereof, affect the rate of decrease of the ratio of the minutiae. And the second one is the Brown-Forsyth test, wherein it is used when the population cannot be assumed normally distributed.
These are the results that we obtained by testing the distribution of our data with a Mann-Whitney test in order to determine the relationship of the variables to each other, specifically what the independent variable, which in this case is the light condition, secretion type, and the substrate, and how they affect the average ratios of the minutiae count. Then we also tested the variance of the data with a Brown-Forsyth test, which aims to figure out under which conditions yield a more varied number, which in our case could point to under which conditions actually has the tendency to have a faster or a greater rate of degradation. This table is a summary of our results for when we tested the individual factors, which is to say that we tested whether there is a significant difference made in the average minutiae ratio when evaluated based on which substrate, secretion type, or light condition it was put under without considering the other factors. So, as seen here, plus is an indication of a significant difference, and the minus means that no significant difference was found. For the tests by individual factors, it was found that prints that were deposited on the plastic substrate had significantly higher average Minutiae ratio than those that were deposited on glass. This is an indication that a higher number of the prints Minutiae survived throughout the passage of time in the plastic substrate than in glass. But looking at the variance of the average Minutiae for the substrates also, it shows that there is no significant difference between the two, meaning the two numbers changed at roughly the same pace. Next is the secretion type, which are the sweaty or greasy. We actually found that the distribution again has a significant difference in that the average Minutiae ratio of the greasy prints is greater than those of the sweaty prints, meaning more Minutiae from the greasy prints withstood the passage of time. In the variance, there is no significant difference, meaning that the rate at which they decreased when compared to their secretion type is homogeneous. Last, for the tests on the individual factors, the light conditions showed no significant results. These results are in agreement with the results of the Alcaraz-Fasol et al. 2015 study. Next is the combination of factors. What we have found is that when it comes to distribution, greasy prints deposited on glass shows no significant difference with the sweaty prints deposited on glass. Then the greasy prints deposited on plastic showed a significant difference to sweaty prints deposited on the same substrate. In the Alcaraz-Fasol study, their test showed that the greasy prints on glass also showed a significant difference from the sweaty prints on the same substrate. Then from the variance of the data concerning this combination factor, there are no significant differences found. The data is homogeneous. For the next combination, the secretion type and the light condition, the average Minutiae ratio of sweaty prints exposed to light bear no significant difference to those exposed to medium light. The same is true for the greasy prints. Next, the average Minutiae ratio of sweaty prints exposed to medium light bear no significant difference to sweaty prints exposed to darkness. That is also the case for greasy prints. Last, for the secretion combined with light condition, the average Minutiae ratio of sweaty prints exposed to light bear no significant difference to sweaty prints exposed to darkness. The results are the same in terms of the greasy prints. For the substrate type and light conditions, tested in the same way the secretion and light condition, there are also no significant differences detected. For the variance, no testing could be conducted because there is insufficient data that could yield a reliable result. These results in the factor combinations are similar to the results of the 2015 study. However, in the variance tests, they had enough data and they found no significant differences there as well. Lastly, we examined if there is any difference between the data gathered from different fingers, since in the methodology of the 2015 study, it described that the Minutiae count that the tests are done on must be the combined count of both the middle and the index finger. The same tests and factors combinations were done for the individual Minutiae count for the index and middle fingers. In this endeavor, we found one difference in results. The difference is that for the index finger, when the secretion type was tested, we found that there is insufficient evidence suggesting that the average Minutiae ratios between the two secretion types were greatly significant from each other. While for the middle finger, there is actually sufficient evidence suggesting that the average Minutiae ratios of those coming from greasy fingers is significantly higher compared to those coming from sweaty fingers. And that was it. Everything else was similar to the results for the test conducted on the combined finger Minutiae ratio.
The main goal is to determine if the IO2 powder from the original study is capable of replication with Sergi silver black powder and with a smaller number of data. First objective was to test individual factors such as substrate, secretion, and light conditions on their own to show an effect of the average ratio of the Minutiae count. Only the substrate and secretion have significant effects on the Minutiae ratios capable of replication. Second was to see which factors combined will give a significant effect on Minutiae ratios when being tested. The results, however, yielded no significant effect for each combination of factors, thus inconsistent with the original study. Combining the substrate with light conditions and secretion type with light conditions, the results showed insignificant differences, which was consistent with the results of the 2015 study. All combinations with light condition could not be tested due to insufficient data. Third was to compare the results of the statistical test done on the Minutiae ratio from the combined count of the fingers to the Minutiae ratio to the two fingers separately. The results on the test for the Minutiae ratio of the middle finger alone mirrors the results of the test done on the Minutiae ratio of the combined fingers. However, the results from the index finger differed only slightly. Furthermore, the following recommendations were drawn. First and foremost, based on the statistical test conducted, having a higher number of samples is highly recommended to determine differences between variables. Second, since documentation, such as photographs, are the ones being studied during data collection, using a tripod to secure the camera to capture a sharper image is advised. Next, a lifting tape is needed to lift a latent print from the substrate to avoid formation of bubbles. Lastly, to achieve a more desirable result and differences between the degradation of prints, the it is better to conduct this research for a longer period of time. This concludes our presentation, and we wish you all a great day ahead. Keep safe.